We are recording. Okay, so today is our 4th week of class. Congratulations on surviving this far. I usually say that at the end of this week, actually, but congratulations on 3 weeks. And we're going to talk about imports and modules and packages today. All right. As you can imagine, for modules and packages, it can be beneficial to separate your code into separate files, so it's more organized and easier to find things for people who are not familiar with your code. Maybe you have a nice file name that says all of these types of functions I'm going to write are going to be in this file, and all of the other functions are going to be another. We'll see that today in today's project. The other thing we can do is we can also import stuff. All right, so we're going to kind of talk about those things really quick. I'm going to start out by showing today's project. Pretend you don't actually have to pretend like you've never seen this before. You've never seen it before. But in the situation that you're facing a project you've never seen, I usually just take a spin and see what's in there. All right, so we've got a main.py file today. And inside we got a folder here called gist search. We're going to talk about what that is in a little bit. We're going to have 2 files there. We also got one called a init. I'm just going to click on everything. What the heck? All right. So let me actually minimize this. All right. So at this point, we've got a lot of files here. We've got our README. We've got a main.py file. We've got a search.py file. We've got a utils.py file, init. And then we just got some other stuff here. So as I was saying, it can be advantageous to make your program modular. Modular means it's going to be in several files instead of just one. That's the word for it. And likewise, individual files are also known as modules in Python. So you could call this the module search, or this one utils. So again, if you've never seen this project before, and you haven't, you might think, well, there's going to probably be some utility functions here in utils and maybe something to do with searching in search.py. All right, and so that's kind of the organization that will help people unfamiliar with your project find their way around. Likewise, you can also, hold on a second, let me just, everyone good so far? Okay. Okay, so likewise, we can imagine there's other advantages to having your code be modular. If multiple people are working on the same file, maybe they're trying to do 2 different goals. So maybe one person is trying to fix a bug, and another person is trying to add a feature at the same time in the same file. If you can imagine 2 programmers working on the same thing, trying to accomplish 2 different things, might step on each other's feet. They might, one person might break someone else's code or something. So by separating it into separate files, it might be easier for 2 people to be working on the same project and not end up having a merge conflict. Remember, when we're submitting our code to the repository, at the end of the day, if 2 people change, if I put an A here and break that, and if somebody else removes the knot, in a separate file. Remember that, let's pretend there's 2 forks of the same thing, okay? If in one fork they make one change on the line and another fork they make a separate change on the line, when you submit those changes, GitHub is not going to know which one to choose. It's not going to know how to choose between mommy and daddy. It's a really bad analogy, but that's what I'm going to do. Anyways, to avoid those things, you can either work in separate forks or branches. We're going to talk about branches next class. And or what you can do is, if you make your files modular, sometimes you can have one function that somebody's working on in one module, and another module, and then they'll be working on completely separate files and less likely to have a merge conflict. But mostly it's just about organization, keeping each of these bite-sized or organized in a nice way that someone unfamiliar with your code can find your functions and know their way around the code a little bit faster. Make sense? Hold on a sec. Ice cream's melting. Too melty. All right. So Likewise, individual files are modules. There's also something called a package, and that's going to be a folder full of files, and it kind of turns that folder into an object. We're going to talk about what objects are next week. But basically, it kind of groups all the data in there. And the way you know, this is called a package, and it kind of, if you set it up in this init file, which is empty right now, you can have it kind of automatically load certain functions when you use it. And you can kind of treat it like an object, which is going to mean nothing to you at this point. But for now, just think of a directory as a package and an individual file as a module. And that's all you need to worry about for now. You can also know it's a package because it'll have this init file. All right, that's how you know. Just that for now, that's really all you need to know. And so that's modules and packages. Any questions about that? Now for the interesting stuff. Let's talk about imports. There are 3 different things you can import in Python. Does anybody know what those 3 things are?
A module, a member.
A what?
A module, a member. That's about it.
Okay, hold on. Let me read the chat too. Oh, my chat. Yeah, packages, modules, functions, variables, class. Okay, so my question was not specific enough. You guys are all correct, by the way. But let me rephrase my question. Where can you import from? Not what can you import. I meant where can you import from? And Don already said modules. That's correct. Modules and packages. What else can we do?
Libraries.
Yep. All right. That's pretty much it. Cool. So let's talk about that. Yeah. Victor, you got it. Standard library too. So there's really 3 main places you're going to get stuff from. They're going to be from separate modules in your code, or packages, for example. So that's code that you wrote. Likewise, you can import things like, remember how we did import random, that very first class where we made that game? You can import stuff. That's the standard library. Those are things that come pre-installed with Python that you do not have to manually install. Finally, the 3rd thing you're going to import from is, remember requirements.txt? These are third-party libraries that we can get from as well that we have to manually install with pip install. In this case, our requirements.txt. Make sense? All right. So generally speaking, you might have, if you have each of those types in your thing, notice how right now we've got one that says import click, and then one that says import search gists from gist search. We're going to talk about this, what this looks like in a second. But this one is, as we can see in requirements, that's going to be a third-party one. Click here. And this one is saying from the package gist search, which is this folder here, dot search, which is this module within that folder, so folder.module. Note that when we do that, it's not saying .search.py. When you're importing from a module, you do not ever need to say .py. All right. And so from there, we're going to import the function search gists. That's how that works there. And so that one's going to be importing one of our modules and functions from it. This is from a third party. And likewise, if we had standard library, we might just say like import random. So a good convention to follow is what I like to do, is I like to group the 3 different types together and separate them by a space. So all of my modules that I'm importing, I put together. All of my standard library things, I group together. And all of my imports from requirements, I group together. So that it's just easier to kind of see how things are grouped. It's not the most important convention, to be honest, but it's kind of nice. At the end of the day, somebody could just type import utils here, and well, if we said this .utils, but bear with me. We could say this, but these import statements, they actually work the same regardless of whether you're importing from a standard library, a third-party library, or a module. So it's really sometimes hard to tell which thing you're getting it from. And so sometimes grouping them together and having them spaced is a little helpful. Not mandatory. Does that make sense so far? Any questions? All right. Now we're going to talk about the different types of import statements. As we can see here, we've got one that just says import click. And we've also got one that says from gist search, import, search gists. All right. So if we go back here, I got a little bit of a reading for you guys that I'm going to walk you through the important parts really quickly. Here's this link. You haven't seen it before. And so what we're going to do, and I'm going to read it to you now. You don't have to read it on the side. So basically, there are different ways of importing stuff. Right now, we're going to pretend we have two modules, one called characters.py and one called main.py. All right. And we've got some really strange names like Vercingetorix. I don't know what that's. Anyways, how this is going to work is we're going to see a couple different ways to import these things, and there's advantages to some, and there's some that we just say don't ever use. All right, so we're going to kind of go over these so you see how they work in the wild. The first thing we might want to do is, so in this one actually, in characters.py, we've got these two characters that we made. And then we've got a main.py that's going to have like kind of run this game. It's a video game that somebody coded basically with really weird character names. And so what's going to happen here is the first way we can do it is using the from keyword. All right, so we're going to say from. Remember the module we had up here is called characters.py, and we don't need to say characters.py. We just say from characters, the module. And we're going to say import Ragnar and Vercingetorix. That one just rolls off the tongue. And so if we look up here, we're in main.py and we're just importing these two variables. And so that's what's saying. It's just saying from this module, import these specific variables. And then we get them and we can use them. This is kind of a nice way of doing it. There's also a way we could just say, and then once we do this, we can just call them by their name, just like variables that were defined if they were defined in this main.py that we're using right here. Anyways, kind of following that, if we do it like this and we import with the from keyword, we can just use the variables just like they were already in this particular module. If we do it this way and we just say import the entire characters module, it's a little bit different. We can still use them, but now we have to preface it with characters.ragnar and characters.vercingetorix, whatever that V word is. And whereas before we didn't need to have the library it's coming for prefacing it. So there's people actually like both of these two ways. The problem with this one is nice because you can see where the library, where that variable came from. All right, so you immediately know with this dot notation that, hey, Ragnar here came from the characters module. And so you can kind of figure that out. It adds a little bit more visibility to where these things are coming from. Whereas here, we're just calling these variables, and you'd have to maybe scroll up to the top of your code where it's imported from to see where it came from. All right, so this has a little bit, this is a little more explicit. But the problem is it's a little bit more verbose. Look at how much longer it takes to write the same thing versus here. If your module is something like a long word like characters, you're going to have a long line of code, and you're going to risk going over that 80 character PEP8 requirement. Remember, we don't want to have our lines of text be longer than 80 characters. All right, so there's some advantages there. Yeah, so you always know where those members came from. Likewise, there's another way. Using the same from keyword, we're going to say from this same module, import star. I'm going to show you this because you're going to see it out there in the wild, but I don't want you to ever use this way. everything. What stars everything? I don't remember what I said. Give me some context. All right. So this way, with the star, is it's just it's going to import pretty much everything, and it's kind of dangerous, and we'll see why it's dangerous. I really don't like this. This will cause you problems. It might seem like when you're first learning to make separate modules, oh, I can just import everything from the other module with import. So you can, but one day it is going to ruin you, and you're going to be sorry. So just don't ever use it. All right. It's always more efficient to import things explicitly, either this way or this way. We're going to see why this goes bad in just a second. Finally, because this was still kind of long, these names, these variables, we can actually give them aliases with the as keyword and say import Ragnar as R and Vercingetorix as V, and now we can just reference them as R and V, and that's going to be an alias for Ragnar in this one. All right. So these can be nice if you have ridiculously long variable names. It can help out a lot. Likewise, this can be useful using this method like this because if you ever have the same variable name coming from two different modules, in this case one is coming from characters and one of them is coming from TV shows, you could alias them even though they were received as the same variable name. You can give them two separate aliases so that they won't overwrite each other. If we did not have these two aliases like this and we just did this, this one would end up overwriting this one and we would just lose that first import. So aliases can be really powerful to, if you ever have duplicate variable names or long variable names, they can make your life a lot easier. Likewise, you can also alias the entire module. So in this case, remember how we started out up here and we had characters.ragnar. When we did import characters, we can reduce that to just import characters as C, and then we can have c.ragnar and c. whatever that is, and it's not as ridiculous. And you also still have that visibility as to kind of where it came from. Make sense so far, guys? All right. So aliases are great. I encourage you to use them. If you guys remember, like pretty print, I usually alias that one we use to kind of print out our dictionaries really nicely. I usually give that an alias. All right, so which one is better? Once again, if we just say import our module name, that's good because you can see where it came from. You're always aware of the origin of the member. Oh, nice. I thought it was just some weird video game character, but who knew? Maybe it's both. Anyways, so we'll get the advantage of knowing where the thing came from. However, it can be verbose, and if we have something like characters, it can be bad because it's too long. So you can kind of combat that with aliases, but this is going to be the most popular one where we say from the module import something specific. All right, this is really nice because maybe they can teach me how to pronounce that word later too. But yeah, we can also do it this way. Again, we kind of see where it's coming from. You do have to scroll up to see the imports to see where it came from, but this way you won't have any trouble. Assuming you can figure out where the thing, what it is you're dealing with and where it came from. This is nice. It's the safest one. All right, it'll be good. And again, if you do have a conflict where you have the same exact variable name, you'll quickly see it here when you're importing these guys, and you can give them aliases to make them different. This is where we can see import star is bad. Well, I think it's bad. It is dangerous though, so I say it's bad. All right. So what happens here is when you're importing absolutely everything. So let's read how this is going. In this case, we're importing time and in module a.py, and we're also going to create a variable called hello world. All right. So this time is different from, we're in a separate module called main. We're also importing time, but this one's from date time. Those are two, I know they're both called time, but they're different, okay? You just have to take my word for it. And so in this case, we're importing time from date time. And so we might be trying to get this variable hello world from module A. So we just say, oh, let's just be lazy. We'll just import everything using star. But what's going to happen is when we do that, we're going to get both of these guys imported instead of, so like when you import an entire file, you're importing the imports as well. So that gets interesting. So when we do this though, we're going to import time from date time, but also when we do this, we're going to import this time, and it's actually going to overwrite this one when we print it out. And so that's going to be a problem. So sometimes when you use star, you'll import things you don't intend to. I've also had a situation where I was lazy once upon a time when I was coding, and I tried to use import star between two different modules, and it was actually trying to, I had like a function. They were both using functions from each other, and so I just had import star from each other. But again, when you import one module star, it's importing those other imports. And so I got into like some kind of weird race condition where they kept trying to import from each other, and then it saw the other ones import and kept trying to import from each other, and it was a bad day. If you know how, like, have you ever got your headphones tangled up? If you ever had those like earbud headphones, everyone's got wireless ones now, but I don't. You get, like, it's annoying getting those untied. It's just like that, but it's worse with code. All right, so don't use star. If you always import things explicitly with this one or this one, you'll be in a much better place. Your code will look cleaner, and you just won't get dirty looks from people from using the import star. All right. Now, any questions with that? You guys are really quiet with the questions today. Either I'm doing a good job or I'm doing a terrible job, and I have no idea.
I actually do have a question.
Ooh.
When you do this for pretty print, how do you use it? And if you set it to print, will it overwrite the natural Python print?
I'm not overriding print. I'm making a separate variable. I just call it pprint, or no, I call it pp, which is, it sounds stupid, but it's shorter. Yeah. So I'll show you how to use that when we get to the project. But
can we overwrite print?
Yeah, but you wouldn't want to.
Okay.
I mean, you can pretty much overwrite anything. You should.
That's fair.
All right. So last thing is this, and this is totally unintuitive, and that's why we're going to cover it. So actually, when we import a module, it also just plainly executes all of the code in the module we're importing. This is totally unintuitive that it does this, so it's really important you know it's happening, okay? So let's look at an example here. We've got this file called emails.py, and we've got a variable called default subject. It's welcome. Later on in the code, we've also got a random function call here that sends an email with the default subject, all right, just out in a while. So you might be able to think that if we use the from emails, this file, remember, no, we don't put the py in our from statement, you might say from emails import default subject. You'd think we'd only get this default subject. You would think. However, it also executes all of the code. So if we did this, it would send an email as well when we're just trying to import this thing. All right, that's terrifying. If you didn't want that email to go out, there are ways to handle this. We're going to see that in today's class. It's just important to know that's happening because, again, that's really unintuitive in my opinion that happens. But generally speaking, you don't usually leave a bunch of random function calls just sitting out in your program, so it's not usually a problem. But if you do, or if you do intend to, we're going to show you how to go about that. Any questions with that? How do you guys feel about imports now? Do you love them or do you hate them? All right. You better love them, because that's like one of the best things of Python is borrowing code from other people. All right, so let's check out today's project. Cool. So if we go here, oh man, hold on one second, guys. I forgot to click on one link for you guys. Boom. Okay, so GitHub also has something called gists, and what that is like a short. You got a question? Nope. Okay. So what a gist is like it's a quick snippet of code that you can use to share with people. So you might think you could use a REPL to share some code. You could just use a snippet in Slack, but Slack doesn't usually persist over time. So this is a really nice way to just, so it's from GitHub. It's called a gist, and it's a nice way to share like a README file or just a couple pieces of code. It could be multiple files in the same thing. The actual walkthrough for how to set up your workspace, that text-based one, that was a gist. So you can use these things to kind of share a snippet of code or kind of whatever you want to talk about, really. We're going to be using those today in today's project. And so this is Santiago's that he's made, and we can click on this and we can see it's just a little short piece of code. In this case, we've got some tests and just some kind of function he wrote, and it's just a quick piece of code that's just stored in the cloud, basically, for you to share with people. All right. Today, in today's project, we're going to be using something. We're going to be building a gist search, and so what this is going to do is we are going to be able to reach out to the interwebs and get information from the internet, from an API, which APIs, if you're unfamiliar, they serve up data for people to use, and so we'll see that. So just think about it like an online database to get information or send information. All right. So we're going to be actually connecting our Python program to the internet and getting live data in today's project. Pretty cool to be doing that on our 4th week.
Jason, would this be different than web scraping?
It's a little bit different, yeah. It's a different library. Web scraping, we use something called Beautiful Soup, and this is going to use the requests library. Requests, remember, it's going to get data in JSON format, which I think I've already told the joke that it's named after me, but whatever. But yeah, it's JSON data is, again, just lists and dictionaries that are nested together, and usually we'll request from an API, and we'll get that data back in JSON format, and we'll be able to do stuff with it. And we're going to see how that works today. All right, pretty exciting, kind of exciting. More exciting for you guys. I've done it 100 times.
Super excited.
Yeah. All right, so here's what we're going to do. We're going to set it up so this is actually going to be a program that's meant to be run from the command line, okay? So the way we're setting this up is we're going to say python main.py, going to file this, we're going to execute it like that down here in the terminal. When we're done, when we're finished writing it, then we're going to pass it a username. In this case, like this is the username for Santiago's GitHub is Santiago Bisulto. And then we can have 2 optional parameters to filter all the results of all the gists that that person has written, either by the description and or by the file name as well. So we've got file names in here. We've also got a description here at the top. All right, so we're going to have those 2 optional filters to sort through, because as you can see, he's got like, I don't know, 102. that he's made, so we definitely want to have a filter for it. When we finish writing the code, we'll be able to execute it like this, Python main.py, pass the user. We're not going to actually need these like less than, greater than around that. It's just for an example. And then we'll be able to pass either a description, a file name, or both. All right. And that'll be pretty cool. So you might ask yourself, if you've ever messed around executing Python files in the terminal, normally you just do Python in the file name, and you don't have all these extra parameters like that, right? Well, there is actually a library called Click that lets you set that up, and pretty much it's as easy as importing it, doing this, and doing this. I'm not going to dive into it right now, but it's pretty straightforward. You just say like, I'm going to have the option here. This is the short name, or you can type in the long name instead. You can just say whether it's required or not. You import that library, and then you just send. And basically, those things that we type in here as variables are received as parameters here in the function once we execute the code. Make sense? We're not really going to go into that in detail today, but if you're ever interested in setting up a command line program like this, it's incredibly simple. You don't have to really understand it that well to set it up. All right. Okay, so today's project, now that I've kind of introduced it, you're gonna have to use your imagination a bit and pretend you're on a team of people, and your teammate got a little bit of a head start on you. You're collaborating on the same project, the same modular thing, and they've written some code here, a little bit of code here, and they've taken care of main.py. In fact, this main.py part is completely going to be abstracted from us in the sense that we don't have to know what's going on. We just have to trust that our teammate has set it up, and that we can, if we do our part, the code will work. Frequently in the real world, that's how it's going to work. You can't like hover behind your coworker's shoulder and be like, hey, how's it going, all the time. Otherwise, you're never going to get your job done. So, so pretending we're working as a team, and we're going to basically jump into the code that's set up here, and we're going to have to first figure out what's going on and see what code is written there, and then from there figure out how we can complete the code by checking the tests. All right, makes sense so far? Everyone feeling good with their imagination here? I hope so. Hold on one second. I'm going to close this one. Bye-bye. Okay. I like to have a clean set of tabs. I'm not the type of guy who has 50 tabs open. All right, so let's look at this guy. We've got search.py, we've got utils.py, and we've got main.py. Now, in the real world, a lot of times when people are trying to tackle, say, a long to-do list or something, there's two types of people. Well, there's probably three. There's people who just won't do anything and they'll procrastinate. But really, there's people who will try and do the hardest thing first, and then slowly keep doing the hardest thing. So by the end, it'll be nice and easy. And there's people who will do the easiest thing first and kind of build up to the hardest part. And there's also people who just do all of it's more than three, whatever. So I actually encourage you guys, when programming, to try and find what the easiest thing to do and do that first. And if you're the type of person who does the hardest thing first, this is going to be counterintuitive, but I'm going to show you why. Generally speaking, the easiest parts are generally smaller building blocks that actually get used in the bigger building blocks. So it's actually harder to do the biggest part first if it uses smaller parts. Like if there's a bigger function and it calls a smaller function, if you don't have that smaller function working, you can't do the bigger function. So finding the smallest part to work on first can actually help you if you can kind of figure that out. So one way to do that is to kind of know the project. Another way is to kind of read the tests or the README to get an idea of that. A third option that we can do is we can follow the imports. All right. We know from the README the main.py file is going to be the main executable. That's kind of like the main file. So this is probably going to be like a wrapper around the other code that's executing other functions. Does that make sense? Everyone following that? So we're going to follow the imports to see what the smallest part is. So in this case, main.py is the main one that we're going to be executing, and so we're going to see what it's importing. This is a third-party thing to run this stuff, but this guy is importing from gistsearch.search, which is going to be this module here, and we're going to import the function called searchgists. So we're going to go to search.py, and we're going to look at searchgists. And we don't really have any code here. It's not really descriptive yet. We'll dive into this in a second. But we can also see that this one is importing from gistsearch.utils, import getGist. So this is not the final or the smallest part of the code probably. So if we follow this and we follow the trail, we can see here finally utils is no longer importing from any modules. This is actually another third-party library. This is the one that we use to access the APIs and get the data from GitHub. All right, so this is going to be the smallest or the part that we're going to be using in here, and this part we're going to be using in here. So if you can kind of follow the imports to kind of get an idea of how the code is interacting. It's not always going to be this explicit and straightforward where it's just one here, and one here. Most of the time there's several imports and it's not going to be that obvious. But this is one way of kind of finding your way around. All right, so we've got some tests here. Can we get a link to this project? Sure. I'll link you here. Oops, wrong button. Yeah, I forgot, sorry. And I'll also link you to this. All right. So we know, because I told you, but also kind of by following the trail here, and as we kind of look at this code, we'll see a little bit better. But utils.py is going to be the smallest part in our equation here. So it appears that if I actually go here and I do py.test, test.py, or actually, what have I done? Oh, hold on a second. Hold on one second. Oh, that's weird. I don't remember this one happening. Okay. There we go. I don't know why that one wasn't in there. Okay, so as you can see, if we look here, high level, 2 of the tests are already passing and 3 of them are failing. So like I said, it's like you're just jumping right in the middle of something. You're not starting fresh. Somebody else has kind of started this. If we actually looked at these and ran these first 3 ones are the ones we need to pass. But these are internal ones that are already completed. It turns out that this utils thing, this function here in utils, getGists, this one is actually already completed. If we run these tests, if I do py.test, tests.py, I actually want to test both of these at once. So what I'm going to do is -k, I'm going to type getGists. The word getGists is in both this function name and this function name. So it should get both of those. And we can see that I've deselected all these other ones that are about searchgists, and I've only checked to see these ones are running. So it works. But ultimately, we're going to be writing search.py here, and we need to use this function here that's already passing the tests in our code to complete search.py. And ultimately, if we're going to be using something in our code, then we need to understand how it works first, right? Otherwise, it's pretty hard to work with something if we don't know how it works. So what we're going to do is we're going to look at this and kind of see how it works first. All right. I'm going to give you a brief overview of what request does. This is that one that will access information from online APIs. Notice this is the URL. It says api.github.com. It's not just regular github.com. It's a special URL that is hosting or serving up information to people who know how to use APIs and get it. So not the average user. So we're going to start out, we're going to import requests. This is one that we had to do our manual pip install for our requirements. Remember, if you're ever starting your own project, once you're in your virtual environment, if you're not just importing from requirements directly like we do in this class, you just type pip install requests. And you can install these libraries one at a time. So like I just did for responses when that wasn't working. All right, so going back here, we're importing that library. And what we have to do is we have to build a URL first, okay? So this is going to be GitHub's API, and we're giving them the path to get to their the endpoint to get gists out of it. Okay. Notice this guy username has the curly braces around it. Anybody have an idea why?
It'll be coming from a dictionary of various users.
Close. We're going to be using this. It's just a string right now, our URL. We're going to actually be using it's base URL. We're going to be doing a format statement on it and plugging in a username so it can be dynamic. Right now, we're only looking at Santiago's stuff out there, but we want to make this function dynamic so that we can ultimately plug in anybody's username. And so we're just going to use a format statement and make this, and we'll build the URL, and we'll plug in whatever username they pass. Make sense? All right. So what we did is all we've done so far is built a URL. Pretend right now we formatted this. It says Santiago Basulto in there, and we're good to go. All right. So the next thing we need to do, and you're not really going to understand this a whole bunch, but we're going to use the request library. We're going to do a GET request. A GET request high level is where we're just asking for information. We're not sending any. We're just asking for information. Okay. We're sending this URL that we formatted, that we just built. And we stored it in a variable called URL. We're sending it that. And we're saying we only want the first 100 results. Assuming, yeah, well, I guess Santiago's at 102, so has a little meaning now. And whatever that returns, we're going to store that in a variable called response. All right. We're going to talk about it's an object. We're going to talk about how that works later next week. But for now, it just returns something that's full of data. Okay. And we need to think about different cases, though. This is actually going to be asking the internet for information. There's a couple of things that could go wrong here. You might be offline. The server might be down. You might have given them a bad web page. Maybe you typed it in wrong. Maybe the username has some funky characters that somebody typed it. I mean, there's a lot of things that could go wrong where this thing asks for information and it doesn't get it, right? So what we need to do here before we just assume that it's good is if it's not okay, so this is a response. If there's like a thing called .ok, if it works, it's okay. It's a Boolean, and we'll learn about that later. But basically, if the response doesn't give us the information we expect, I want to return none to signal back to my program that something has gone horribly wrong. Or not horribly wrong, but, whoa, get off my lawn. All right. So if the response doesn't work out, we can do that. Finally, if we get past that, that was kind of like our check to make sure things are okay. We're going to take our response, turn it into JSON format in Python, and return it to wherever we're storing this. So when this function runs, it's either going to send none back or a JSON file or a JSON variable full of information. Remember, JSON could either be a list of dictionaries or a list of lists or a dictionary full of lists. Or you don't know what the actual structure is. It's just going to be a bunch of nested lists and dictionaries, though. All right, make sense so far? Let's see how that thing works in action. Okay, so what we're going to do is we're going to test to make sure this thing works. All right, so what I'm going to do is I'll say gists equals get gists, and then I'm going to plug in G Van Rossum. Anybody know who that is? Jordan, who?
Inventor, Python inventor.
Yeah, the guy who made Python. All right, so we're gonna see what he's been up to on GitHub. Okay, so what we're gonna do is I'm also just gonna get the first 3 of them just because it's a lot. How do I get the first 3 items in a list? Whoops. Anyone remember? No, we don't actually have to import JSON here. Good question. With requests, you can just do .json on it, and it'll know what to do. Yeah. All right. Anyone remember how to get the first 3 items out of a list?
Andrew's got it in the chat.
Oh, okay. Thanks. 0 to 2. All right. So let's do just 0. 0 to 3. Remember that 2, the 3 is not inclusive. You are really close though. I just do that to check up on you guys to keep it fresh. All right, so once we've got it there, we want to just kind of loop through it to see what we've got. So I'll say for gist in first 3 gists. Notice, remember, I always do plural for the collection, and then I can always just do a singular in plural, and it just reads out like it makes sense. So at this point, I'm just going to print. Well, let's look at what we're getting first. It's kind of hard to print it out. It's going to be, we don't know what the JSON data looks like. So this is the thing. Whenever you get JSON data, you have to look at the structure. If it's a dictionary, you have to know what the keys are. If it's a list, you have to know. You gotta look at it first, basically. You never know. Well, I mean, sometimes they'll have documentation to tell you what you're getting, but just look at it. So we've got a file called sample.json here, and this is what it looks like. Hold on, let me get out of the way. All right, so we can see here that it turns out that this one is a list of dictionaries. So we've got a list on the outside, and then each of these, all the way to here, is one gist. So basically, each of these is representing a gist. It's a dictionary, and we've got just a ton of information here. We've got the URL, the forks, the commits, the ID, files, public, created, add, update, description, owner. You get, generally speaking, you're going to get a lot more information than you care about. So what you do is you kind of skim through it, see what seems relevant, see what you're interested in, and then you use that information. For this case, we're going to just do the ID, and we're going to get the description real quick so we can kind of print it out. So what I'm going to do, I'm going to put that there. This is just a, I mean, doesn't matter what, let's not do anything special, it's just a string. And I'll do that format, and I'm going to do, so remember, each of our dictionaries now, this is good. First 3 gists is a list on the outside. You have to keep in mind the structure here. The outside is a list, so we're just looping over a list, okay? And each item gist in first 3 gists is going to be a dictionary. So each of these, every time we do a for loop, we're going to get looking at one of these dictionaries individually. And I want to look at the ID key, and I'll look at the description key right here. All right, so if we go here, we say gist, which is going to be each individual dictionary, ID, and we'll say gist at description. And if I run this, hopefully everything is good. Ta-da! This is from the internet. This is live data from Guido himself. All right. So this is the ID here. This is the description. Pretty cool. If I took out the first 3 gists and I just said gists, we'll probably have a few more. Okay, he hasn't written that many. Not everybody likes GitHub gists. We can also, to prove it, this thing is really working, we can do Santiago. Oh, whoops, I didn't do Basilta. Oh no. Well, there's another Santiago who's been busy. And we can see that Santa has been busy. It's pretty cool getting information from the internet. It makes you feel like you're finally starting to do something. So I'm excited about it. All right. here's the problem with this. Let me make this back to this. Here's the problem with this though. So I'm going to put this back here. Ultimately, if we run main.py, we haven't really set it up. We haven't written search.py yet for this thing to work. But if I go here, and if I type Python main.py at the bottom, and I do user, let's call it Santiago Basulto. If I do this, nothing should happen. Well, I should have put G Van Rossum. I kind of hard-coded it right now. That's not Santa's stuff. But you can see I'm executing main.py, but for some reason, it's showing this stuff in utils.py. Anyone know why? We did just talk about this. No, it's not set up in a net. What's happening is, yep, Todd's got it. It was imported. So what happened was main.py imported search gists, or search.py. Search.py imported utils.py, and it executed this random stuff that's just left out there in the wild. Like I said, this is something you have to be careful about. When we run main, this was just us writing this just to see how this thing worked. This was just us testing it out like kind of a playground, just messing around. We don't actually want this code to be executed when we run main.py, the actual thing. All right? So, and I don't really want to delete this or comment it out either. So there's actually a way to make it so this code only executes when I'm focused on this file. And so if I run main.py, it won't execute it, but if I run utils.py, it will execute it. The way we can do this is nothing more than a simple if statement. We just say if oh, I don't have that backwards. And so what this does, let me see if that worked. I might have the, okay, good. Sometimes I get the quotes on the wrong side. So what happens, what I just did was, behind the scenes, Python has these little variables, all right? And there's one called name. And essentially, this will evaluate to true only if I explicitly execute this file by hitting run when I'm on this file in the tabs, or if I do Python, not Python, just search /utils.py. If I do it down here, it'll work as well. But if I go and I run Python main.py, nothing happens. All right, so behind the scenes, Python has a variable called name with underscores around it, or dunders, and if that's the main file, it'll name it main in the background, and you can make it so this code will only run if it's on this file. The advantage to this is if you're importing stuff, now you don't have to worry about this code being executed. You can leave it here, you can mess around with it, you can hit run, you don't have to comment anything, you don't have to worry about all that. It just works. Does that make sense, guys? Any questions? All right. Notice we're also doing it down here. If this is the main file, run this function automatically is what it's saying. All right. All right. Everyone feeling good about that? Everyone knows how this works? Everyone feeling comfortable? I'm going to wait 10 seconds for questions.
Just Ronak here. Can you explain the main part again on the right-hand side?
Yeah. So behind the scenes, Python has this name variable. And if the file is being run, if you're focused on this file, like, and you're hitting run when you are executing explicitly this file, or if you type in Python utils.py like this, wherever it was, you're still executing this file explicitly. You're not executing main and then importing this, you're only executing this file. So if you do that, whatever file is being executed, Python has a variable behind the scenes that you don't really get to see that it names, it's called name, and it sets it equal to main as the value, as the data in it, if that's the main file being run. And so we can take advantage of that happens and make it so this only gets run if this file is being executed explicitly. This is a really good way to, if you're working on like just one little module in a larger scale project, you can have whatever you want here and you won't get in anybody else's way because it will only get executed if you're running your file. Make sense?
Yep, thanks.
Cool.
Hey, Jason?
Right. Yep.
A question. Since we're just learning about modules and importing a lot of things, is it a wasted practice, or should we get into a practice of once we've imported something to at least run it to make sure it works or it's something proper, especially it being a third-party imported module, to make sure it doesn't screw things up later on?
Generally speaking, if you're not familiar with the module, yeah, I'm definitely going to play around with it and see how it works. Otherwise, I'm not going to be able to use it. Documentation is hit or miss out there. I want to say when you're actually developing code, you're going to spend at least 30% of your time reading documentation, and some of it is terrible. And you just have to like suffer through it. Some of it's wonderful, rarely, but you'll be happy on those days. But yeah, generally speaking, if I'm ever dealing with anything new, I want to see how it works and become familiar with it enough to the point where I'm really comfortable with it and I can use it and know all the features. Because sometimes like there might be one additional function or method or something in a library you're importing that does exactly what you're trying to do, and you just read the first one, you didn't read far down enough in the documentation or something like that. So mess around with it, get familiar with it, find out if there's any problems. Likewise, if you're doing these things, it might help you write in your test cases so you can know the different edge cases to test for or errors or bugs to look out for. So I would say, yeah, as a habit, you don't necessarily have to do if name equals main. Usually what I do is I just have like a separate outside of the project Python file sitting around that I just mess around in and try things out, or you can do it even inside the project, and I just delete it or leave it commented. I just kind of have it as my playground just to mess with things. It is definitely beneficial to be really comfortable with everything you're using. All right, so we know how this works. Yeah, good question. We know how this works. The next thing we need to do is build search.py. So as like I said, if we don't know what to write here, and we really don't, the README kind of says how this is more like how a README is in the real world. It just says how to use the thing. Sometimes it says how to install the thing. Sometimes it says how to use the thing. Sometimes it says how to reach out to the team working on it. Like there's a lot of, it varies. In this case, we don't have enough direction just by reading this. So we got to figure it out. The way we're going to do that, let's read the tests. All right, so today we're using something called responses. So back to test-driven development. In this case, we are testing stuff from the internet. If you can imagine, that's pretty rough. Again, you wouldn't be able to run your program offline. You wouldn't be able to, if the server went down, your program would stop working, or you wouldn't know if you broke something or not. If the information on here changed, like if you got a JSON file of this right now, and Santiago added one more gist on this thing, it would break all your tests. So that's a problem for test-driven development. And so what we do actually is we're going to download, we actually have downloaded sample JSON data from this already that's from the wild that's not going to change. We've saved it to our disk here so that we can use this and run our tests offline and have the data in our tests that we're running it against always be consistent. All right? So it's pretty important when you're dealing with the internet and you want to write good tests, get some static data that's not going to be changing, that can work offline. In this case, we're going to be using the responses library to access that data pretty much. So don't really worry about responses, just know that it's loading that JSON data. All right, so we are testing search gists, the description. So that's where they pass the description. There's also one where they pass the file name, and there's one where they pass both the description and the file name. So let's look at this. They're sending it search gists, and whatever gets back there, we're going to store it in gists. That's whatever's returned. We're saying that thing should only have one item in it, and we're going to look at that first item. Again, we can see that from this notation, it's probably a list because we're accessing it with an index. Now remember, we could have an integer key in a dictionary. We're not sure, but we do know that the JSON data is a list of dictionaries, and we're just filtering it. So intuitively, if we can follow that trail, we're just filtering and making this list a little bit smaller and removing some of the gists that don't match. So a result should be a list as well. And then after we get the first item, we check to make sure the length is right. Then we just look at the first item, and we just compare a couple key values in that particular dictionary to make sure it works. We do the same thing with searching by file name. We just make sure we only get one result. We do the same thing with searching for both. We only want one result. We only expect to get one result back when we search for both. And then we just kind of compare keys and values to make sure it's the correct result. So that's the idea from it. Still not a huge chunk of detail, but we know we're supposed to get a list back, and we know it's supposed to filter according to description and or file name. So we're just going to have to kind of figure it out. All right. Any questions so far? We're going to dive into this thing. All right. No questions. So the first thing we're going to do is we need to be using this function that we just got. All right. So we're getting a username here. We want to send it to our get gist thing. So we're going to do the same thing as before. We're going to say gists is equal to get gists, and we're going to send it our username. All right. At this point, we're going to be sending whatever. So remember, main.py, we're going to type in our username here. And if we follow the trail, main.py, we're going to get our username here as a variable user. And the first thing we do is we call search gist, and we send it that same variable they typed in right here. And then we're going to just get it here in this function, and we're going to send it right on over to this guy. So it is really important to be able to follow the trail and kind of familiarize yourself with foreign code that's not yours. For me, and this is not easy reading other people's code, it just takes practice. Even myself, it takes, like when I'm looking at a big project, it takes me some time to digest it. Usually I have to look over, walk away from it for a while, look it over again later, and like eventually it slowly sinks in. So don't expect these things to just pop into your mind. All right, so we're going to get our gists, and remember, because we took the time to understand this function and test it out, if I typed something in and it was like a bunch of weird numbers and I ran this, nothing happens. Okay? Remember, it can either return none if it doesn't work, or it can return our JSON data if it does work. We need to handle that here. In this case, this is just us sending the bigger function a signal that something went wrong if we return none. All right, so at this point, we're going to send out our username. They could, we're not kicking them out of the function if that's, or we're not saying like, hey, your program's broken. We're going to give them a message now. So if I'm just going to say if not gists. All right. So if no gists are returned, remember, really quickly, actually, I do need to show this. Yeah, there we go. So I probably showed this before, but I really can't show it enough. remember in Python, your variables are truthy or falsy. So we don't explicitly have to say some kind of a thing like if just equals true, or we don't have to explicitly say if just equals 5 or whatever. You don't have to have a full condition. It can actually, every variable with whatever's stored in it actually has a truthy or a falsy value that just evaluates a true or false without having like a full condition here. All right, so basically, if we look at it, none evaluates to false. So if I just said if none, that's going to evaluate to false, it won't execute this. Because remember, whoa, I can't type. So remember, none here, that's like saying if false. None, it kind of simplifies into false, if that makes sense to you. And remember, for an if statement to execute, it has to evaluate to true. Whatever the condition is, has to evaluate to true. So if I said if Jordan equals here, then this, whoops, hold on, did not mean that. Okay, I'm really having trouble highlighting. This would execute. All right, because that evaluates to, this would evaluate to true. Jordan is here. And so it would be like if true, if you simplify it, right? Okay, we can do the same thing with truthy or falsy values. So in this case, if none would evaluate to if false, and then that would not execute because it's false. Does that make sense to you guys now? How we're simplifying that? So it's important to have these memorized, and it's actually not that hard. Generally, anything empty evaluates to false. Empty string evaluates to false. Empty tuple, empty list, empty dictionary. False evaluates to false. None evaluates to false. And numbers that are 0 evaluate to false. All right? It's just like things that seem empty. All right? So if I said, if this won't execute because that'll evaluate to false, right? But if I said, if Jordan, this will execute because it's got something in the string. Everyone kind of following how these work? It's kind of an important, Python's pretty cool that it lets you do that because it lets you simplify it. So I could just say, if I'm saying if not justs, what's happening is, what if it's a float 0? Same thing, 0.0. Good question. If there's one white space, that's something in there, it would evaluate to true. Excellent questions. Yeah, it's just stuff inside it means it's true. So if I look at this statement, remember how if just is none, that would be like saying if not none. All right, follow me here. Which remember none would evaluate to false. That would be like saying if not false, which would evaluate to if true because the not would invert the false. So that would execute. Kind of a pain in the butt to think about that. So what I like to do is I like to not think about it. And I just say, I read the word not like no. If there are no gists, then there's a problem. Then we got none back. Does that make sense, guys? I'm going to say print user no data for this username for, actually I'll say, for username blank dot format username. So in this case, we're going to give them an error message. If just does not return data, we're going to send them this and let them know there's something happened. So yeah, that's my trick. I just read it. If I said if just, that means if there was data there. So I just read it like English, and I try not to think about it so hard. It's actually easier. All right. At this point, I'm also going to use the word return. Anybody know? Oh, I forgot to show you guys this. I'm sorry. I went too fast. So really quickly, let's backtrack. Here's our function, search gist. We get a username, we get a description, and a file name. What are these guys? What kind of args? There we go. Jay's got it. Default arguments, aka optional arguments. All right, so what these guys do is, so forget about this noise for a second, they're optional. When I call this function, search gists, I have to pass a username, so I'll say Santa, but I can run this function like this, and I could say description equals hey. I could do it like file name equals hey. I could do it like, there's a lot of hay going on here. Somebody get the horses. All right, so in this case, we have all 4 of these ways of executing this are going to be just fine. Except I didn't name file name the same, but don't worry about that. So in this case, if I don't send anything but Santa, it's going to automatically set these variables to none when it executes this. It's like saying, if I don't pass them, it says description equals none. I mean, it says it right here. And so it just sets those up for you. If you don't pass the variable, it's okay. It's saying we've got some defaults. If you don't send it, I'll just make it none. All right, make sense? Those are really powerful for having optional arguments. This is great for like what we're doing right here. This is a search filter. They have the option to search for the description, the file name, or both, meaning we have to make them default so they can work in any of those possible ways. Where did I go? Wrong tab. All right, so in that case, we can do this. It's nice to, when you use those, notice there's no spaces around the equal sign. This is saying this is a keyword argument that we're sending as a default argument, and this is connected to this. It's when you see default arguments, it's more readable to have no spaces around these keyword arguments where it's like a key and a value here, if you just see them together. All right, so that's the convention, and that's going to enable us to have optional description and optional file name. All right, so let's see this in action. There's 4 cases that we have here that we need to consider. And I really want you guys to think about these every time you're dealing with optional parameters. Think of all the different cases. So if there's 2 optional parameters, there's 4 options. 2 to the second power, basically. They don't send either of these. They send one, they send the other, or they send both. All right. If there were 3, it'd be 2 to the third power of the 3 different combinations, or the 8 combinations. So in this case, we need to think about all of them. The way we're designing this code, if we look at the first line, remember default values. We're expecting these to be strings. So if it's an empty string that they send, or none, either one of those, it's like not sending it. All right, so that would evaluate to false. All right. So what's happening here is if they don't send a description, if there's not a description and there's not a file name, remember that's how I'm reading it, so I don't have to think about it so hard. If there's neither of those, we actually want to kick them out of the program. We didn't design it so that there needs to be a filter, basically. Make sense? That's just how we're designing it. Could make it so it doesn't matter. But the first case is if they don't send either one, we're going to give them a message and we're going to return. What's happening here? Why is there not anything after the word return? Anybody know? What's it doing? Yeah, Victor's got it. So by default, it's returning none. So contain yourself, Jordan. Okay, so yeah, it returns none. You don't need to actually explicitly type out the word none. By default, if you return and you're not returning anything, it returns none. So that's kind of how that works. Okay, but I actually like to type none just so I don't have to think about it. Remember, as a good developer, it's nice to make whoever's reading your code not have to think for even a second. If you have good code and you have good comments and you have well explained, remember, Python is, have you guys read the Zen of Python? Tangent. Did I show you guys this before? It's supposed to be explicit, simple, maybe complex, but readability, you know, all these nice things that you'd like code to be. I'm gonna give you guys this link. It's a nice like bedtime poem. All right, it's not. So anyways, I like to not make someone think. If most people, if you really dive into Python, will be able to figure out that that's returning none. But if there's someone newer, they might not know. And if your code is really good, someone new should be able to read it. So I would just say type out none. Either way is actually fine. All right, so this case covers if they don't send either description or file name, we want to kick them out. We're going to give them a message, return from this function, just give them nothing. All right. At that point, if we've gotten to here, then we know that they've either given us description, file name, or both. It's one of those three because this would have made us leave the function. So we're getting one of those. The next thing we're going to do is we're going to get our data from the API using our getGist function that we wrote over here. We're going to make sure that we get some data back. If we don't, we're going to give them another message and kick them out again. So at this point in the code, we should have data in JSON format, and they should have a description, a file name, or both. All right. So if you kind of code it top to bottom like this, you can kind of control, and you'll know what kind of information there is at this point by kicking them out if there's not what you expect using return statements. Pretty cool. All right, now we actually have to do the thing. So let's look at this again. We're going to have optionally a description, and we're going to have optionally a file name. All right, so what we're going to do is when we're trying to filter out some stuff from a list, remember, it's easier to make a new list and append to it than delete from the original list. Not only because it's actually easier and less computational, but you won't mess up your raw data either. So it's twofold better. All right. So when we're filtering a list, we're going to make a new one. I'm going to call it results in this case. I'm going to make an empty list. And just like I said, I've probably said this before, I like these little easy wins when I'm dealing with stuff. I'm also going to just go ahead and return that at the end. I'm just going to get some really easy, not thinking required things just to get the ball rolling. It sounds, again, it sounds really like, so what? But if you're stuck, sometimes writing those 2 lines of code will be like, well, now I've typed something. I feel confident enough to type one more line, and it just kind of snowballs in a good way. All right, so, all right, we're going to do this. The first thing we need to do is we need to look through our gists. How do we do that? Index would work, but that's a little more manual. You'd be like hard coding looking at a specific one vector. For loop is we'll be able to loop over all of them. Yep. You got it. Nice, Scott. All right, so we'll do for gist in gists. All right. And now we are looking at each individual JSON file, just like we were before in utils when we were kind of messing around with that. So we've got each JSON file, and now we're going to have to deal with our filters. We'll start with description. So, whew, all right. Let's see here. So we'll just say if description and if file name. All right. Now that might not be intuitive yet. Let me explain what I just did. In this case, we still don't know at this point in the code. We know they're searching for description or file name or both, but we don't know which ones yet. And as you can imagine, as we're filtering this, if they're not searching for description, we don't want to filter by description. All right? So the first thing we're going to do is we're going to check to make sure they're actually doing the thing before we decide to filter by it. That make sense? We don't want to append or add anything or whatever until we verify we actually care about it. So that's what we're going to do. All right. So let's look at description. Let's look at the JSON data. Let's scroll through here. Here's description right there. There's a key called description inside our JSON file. And remember, we're looping over our JSON file, so our JSON file is going to be called gist. All right. So all we want to do is we're going to have a keyword like time, and we want to see if it's a part of this description. Anybody want to help me do that? It's not that bad, I promise. Jordan, you're not allowed. I'm checking the chat. All right, Dakota, you are exactly on the right track. Victor, you're on the right track. Yeah, in is the word for contains. That's correct. Okay, you guys are getting it. Okay, so our variable is called description. So what we're going to do is say if description in gist at the key description. If I could just type, that'd be phenomenal, right? I mean, so if we look over here, that gist description is going to get us this, and so this is our value. We're going to access the value by doing gist a description. We're going to say whatever the keyword they're passing here, if that's a part of this thing. Not that bad, right? Anybody have an idea how to make it case insensitive? Case insensitive, so like capitalization doesn't matter. Okay, Todd's got it. So all we need to do is, okay, everyone's got it, fine. You guys are a bunch of experts. Just, why don't you teach the class, all right? Okay, so we can do lower on both of these guys, and that will temporarily make everything lowercase, so that it'll remove capitalization from the issue. It won't change any of the data. It's just temporarily making everything lower, just so you can see if there's a match, and then we're good. Yeah, you can also do upper. You can also do .title. There's a whole bunch of things you can do. I like lower because I'm a lowercase kind of guy. But if you're a capitalization person or an upper, if you like caps lock, that's cool too. All right, so if that's a match, if our description we're looking for is a match inside here, at this point, we can do results.append our gist. Okay, it's good. All right, same concept for file name. If we're searching for a file name, we got to look at the structure first. So we've actually got something called files here, a key called files. And we have parse timelines and test.py. So these are the files. It's a little bit different. This is not just like description where it's just a one key value. We're dealing with something nested now. We've got a key called files, and we've got multiple files. We've got the file name as the key then inside here, and then we've got another key inside there called file name to get this file name. Now, I'm going to take a moment to say I don't agree with this structure of their JSON file. They are having to manually come up with a variable name here for a key when they shouldn't have to do that, in my opinion. I would have made this a list instead of a dictionary on the outside and then had this, because right now they're repeating data here. This is the key here, and it's right here. In this case, I would have made a list just to use index as the key because they're having to pull a key name out of their hat. Does that make sense to you guys? Like, this is extra work on that part. I don't like it. But in this case, it's actually, as much as I'm talking crap about it, it's actually going to benefit us in today's way we're going to solve this. All right, so we need to access the key files. And we could dig all the way inside each of these to access this. We really can, and we can if we have time and want to, but because the file names are actually just the keys, we can just look at the keys of the file name and get what we're looking for that way. All right. Anybody want to take a stab at how to find that? If the key is a match? Oh, let me see here. If file name in just files. File name. Okay, so with file names, that's the right. I probably would not do lower on file names because capitalization can be sensitive on file names, depending on what operating system you're in and whatnot. So I would not do kids, but so if file name in just drop files. You've got the right idea, Andrew. We could do if it's in there. The problem is that there are, actually, hold on, let me think about that. That might actually be okay. Hold on. Why was that a problem? I remember it was a problem. Okay, so the reason that's not going to work, and it sounds like it would, actually that's like a really good solution, but if we just did if file name in just files, remember just files is going to be this, I keep clicking on the wrong thing, it's going to be this dictionary here. This is, whoops, it's going to be this dictionary right here. And so really when we do just files, it's going to give us, remember, if you ask for that, if you use in on a dictionary, it's going to get us the list of keys. So if we, it's going to actually say if file name, what's going to happen is it's going to say if file name in, and it's going to be in a list of exact Python file names. So it's going to be whatever parse timeline delta, whatever that says, .py, and then test stuff, whatever the other one was. And so the problem is it has to be an exact match to use that in statement right now. You could do that. We could access it that way. That will work, but there's an easier way. Let me check. Let me show you guys. So in this case, if we did it this way, it has to be an exact match because it's just when you use in on a list, it's just saying is this the exact thing as one of the elements, right? You guys following that? What we have to do actually here is make a for loop. All right, so let me show you what I'm talking about. Oh, Andrew, let's see here. Yeah, I think you got it. So I'm gonna, now this is where Python gets a little bit shady. Well, not Python, just variable naming. I'm gonna call it fname because we've already got a variable called file name. So it's kind of tedious. So I'm going to say for fname in just files, if file name that we're searching for, we'll use the in keyword still. If file name in fname, we can then append it. And I'm going to use a break statement here. Do you guys remember what break does? Break?
Yeah, it holds off the program from running at a specific point, keeps it from just continually going on. It holds off, right?
It takes us out of the nearest for loop. So basically it backtracks indentation until it finds the nearest loop. It could be while loop too. And in this case, it skips over if statements. It finds the nearest loop, finds the for, kicks us out, and puts us right here. All right. So what's going to happen is I don't want to append multiple times. If there were two files here named the same thing or that it found and matched the keyword twice, I don't want to append it twice. Does that make sense? So I'm going to break, kick it out of the for loop so it stops, and we're good. But wouldn't I try to match the file name with the keys in the gist file? Yeah, that's correct. So it just so happens the way this one is set up, Jay, is that this is a direct match of this. They were trying to be creative with the key names, and so I actually took advantage of that and just looked at the keys instead of diving deeper to get the same thing. Make sense? Yeah. We could dive into it. We could also say, we could do for file name and just files, and we could say for in file name at what's it called? File name. So I could just put this right here, and that'll work as well, because this will get each of those guys. Actually, I would probably need to use .items there if I was going to do it like that. No, that's good. Yeah. Fname is currently just a key, which is a string. I need to use the value to get the other dictionary. Does that make sense? I can show you guys if you guys want. All right, so what's happening though is if there were multiple files with the same search term, F as our file name, I don't want it to match multiple and append multiple times. So I'm going to break as soon as it appends once. If it finds one match, I kick it out of the for loop, and then it's good. You guys following? It only kicks out of the nearest for loop, not this one. All right, so let's look at this and let's talk about it for a second. There's one, first of all, before I go any deeper, there's one easy optimization I can do here. I could actually move this up here and put the and keyword instead. So basically, let's read through this. If they're searching for description, then we care, and we're going to try and see if it matches our filter. If they're not, it's going to fail. Remember, and it does not even check the right side if the left side fails or is false. So in this case, if we're not searching for description, it's not even going to check any of this stuff. But if it is searching for description, then we're going to do the check. And if it matches the filter, we'll append it. So we just threw an and there to save lines like that. Make sense? It's kind of nice. Notice it's not ridiculous what we did there. See, this is the 80 character mark where we don't want to go past this line to have our code readable. The reason that is there is so we can have two things side by side if we actually want to. All right, so in this case, we are appending if that works. We're appending if they're searching for a file name and the file name matches, we're also going to append. All right, so let's run the tests. I'll just type search. I expect 2 to work and 1 to fail. Okay, I meant to do py.test. I don't know where my head is. All right. It's still working. All right. So let's figure out what's going on here. Hold on a second. That's weird. There we go. I don't think I had this saved. Remember, when you're running your test, you have to make sure there's not a circle here. Look, if I make a change, there's a circle there. Make sure you save with Control or Command S before you try and run your test, because it's not going to know. Okay, so this is working, but one of them is still failing. And if we look at it, it's test search, gist, and description and file name. It's saying that, and let's try and figure out what's going on. It's saying when it's searching for both of these filters, it should only get 1 result back, but for some reason it's getting 3 results back. All right, so that means our list that we're returning has too many items in it. All right, so to figure this out, we're going to trace it backwards, and we can see, well, it probably has something to do with these append statements. And it's failing specifically at when it's searching for both. So let's look at this, and let's walk through it. So what's going to happen is, let's see what the chat says real quick. But wouldn't that try to match the file name with the keys? I can, oh, okay. Got you. All right, so let's think about both. If it's searching for both, description and file name, if the description is matching, it's good. We're going to append it. If the file name is a match and it's good, we're going to append it. But hey, whoa, 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 whoa. something's wrong there because we just appended the same thing twice. If it matches this one, we're going to append it. If it matches this one, we're going to append it. So that's what's going wrong here. That's how we read the tests, we kind of identify what's going wrong, and then we kind of try and figure it out in the code. All right, this is important to learning how these things work. All right, so let's figure out how we can change this. There's a couple ways to go about it, and I'm going to show you them. And we're going to evolve to the optimal way. And we're going to finish right on time, I think. All right, so let's check it out. So basically what we need to do is we want these append statements to be exclusive. We only want to append once if the thing matches. All right, so let's just change it to if elif. And now these are exclusive. Remember, if statements, it'll check all of them. But if elif statements, it'll only run one or the other or the other. All right, so we'll just make 3 cases. Elif, it's searching for both of those. Then we'll check if this is a match, and then we'll check if that works, then we'll do all this. Okay, this is getting ugly on purpose, but I want to walk you through this. So we can do it this way. Now, if it's like this, we're going to append, or if it's just a file name, we're going to append, and otherwise it's both we're going to append, because these are mutually exclusive. However, there's still a problem. If we run this test again, let me save it first. We did not save Christmas. No, it still sucks. The problem now is if they're searching for both description and file name, well, it is searching for a description still, and the description is still a match, and we're going to append it here, but we forgot about file name. You know, we didn't check that here. We're only, because of the order of our if-elif statements, we have only checked for one. So what we have to do is, to solve that, is there's 2 ways we can solve it. We can put this at the top and do the most complex one first, and by process of elimination, we try first doing both, and if it's not both, then we know it must be one or the other, right? So if we do it in that order, kind of like the waterfall effect of process of elimination, it's kind of a weird one, but we can see that if it's not both, then they must be searching for just one or the other. And so we can tackle it that way. Remember, these are if-elifs, so they're mutually exclusive. And this will work, I think. Boom. Any questions with that? There are other ways to deal with this. For example, if we don't want to, okay, hold on, before I talk about other ways to do this, think about this right now. There's 2 search terms. We have one case here where they don't search for either, and we have all 3 of the other cases. If you can imagine, that's 2 to the second power, options, you know? So if there's 3 search terms, suddenly we need to have 8 if, elif, 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 elif statements. That's a nightmare. On top of that, this code is redundant. We're doing the exact same logic here as we are here, and we're doing the exact same logic here as we are here. This is bad Python code. We don't want to do this. Another way of approaching this thing, by the way, is if I go back here and I do elif, you could, if you don't want to mess with the order, you could say if description and not file name, if file name and not description. You could do that so you are being a little more explicit about the different cases. This will also work. So if we do this, this also works, but it still sucks. We don't want to do this. We didn't take some cool Python class online to use this garbage and repeat ourselves, all right? No. What's up,
Hey,
Don?
Jason, could we word a function that whether we have these 2 parameters or whether we have 20 parameters, could there not be a simple function that if anything is found, it will return it, whether it has a description or whether there's a file name or any other type of thing, as long as there's one element that exists within the parameter, it will return something?
I'm trying to, hold on. You can, hold on. I'm not sure I'm following you. Hold on. If there's one thing, what do you mean? Just return? We're trying to filter it here, right? So if you're just saying if there's just one sent or return.
Right. If it scans through, and while it's running through, it finds, if it finds a file name, fine. But if it doesn't, then it, whatever. Because like you said, I mean, if we have a multitude of different parameters that it has to search for, it just finds something to return.
I think what you're saying is if we have multiple search terms, if say they sent both description and file name, if it just finds a description, that's still good?
Correct.
Yeah,
right.
You could code it like that for sure. In that case,
and that would eliminate a lot of issues, right?
What we had the original way would have been fine if we just had if description, elif file name. That, well, actually, no, if description, if file name. Well, I'll show you what we're going to do in a second. But yes, you could do that. I have to think about it for a second. So these ways work, but go for it. 929, okay. $28. No. F name. Oh wait, hold on. F name is not that. Remember, when we do just files, where we go, is going to be this whole thing. But remember, when we use the in keyword on a dictionary, it gets a list of all the keys. All right. And so basically, it's going to get a list of parse time deltas in test.py. So it'll be like parse time deltas test.py with quotes around those. And it would be like saying for fname in this. And those are just strings that are keys. Okay, these are both strings. And so it's just looping over these two strings in this case. It's not actually getting the values. I think what you're thinking of is if we did like .items or .values on our dictionary, we would be getting those instead. Make sense? Then how come fFilename and fname works? So file name, okay, so at this point, fname is a string. So fFilename, let's just say it equals time. And let's say fname equals parse time deltas. Or fname, I might not have that. Hold on, let me check. For fname, and just files. Okay, so this is the string. So basically, we're just checking if time in, oh my gosh, parse time deltas. And time is a part of this word. It's kind of how that's working. You following? No, that's a good question. I want you to understand this stuff. All right, let's check this out. So at this point, this code sucks. It's redundant. Honestly, this works. And remember, in this course, if you're ever faced with something, just get it working at first. Don't worry. Like, make it efficient later. You know, get something going. Like, get something on paper that functions. Okay. This is actually probably what I would have done the way, or like, not, maybe not the in not, but just like if elif, and I would cascade down, do the most complicated first. But it's terribly inefficient, and we're going to see a better way to do it now. All right. So what I'm going to do is I'm going to get rid of this code, and I'm going to have you guys think about this problem upside down. Whatever that means. So what I'm going to do is, let me get rid of these guys. The thing that we were doing here is we were like I was saying earlier, actually, if we had it that other way, every time we added another search option, it would be exponentially more if statements we have to do, which would be horrible, and we have to repeat ourselves a bunch. It just does not scale well. So what we're going to do is we're going to think about this a different way. It's unintuitive. I did not naturally think of this myself. There are some things in programming you just have to see someone do, and you'll learn them. Somebody else had a lot of time on their hands, and they figured this stuff out one day. So you don't have to be that person. Be grateful. That's why we do Python, so we can import libraries and not be that person, so we can have lives. So anyways, we're going to do this backwards. The way we're doing it before is we were thinking about, hey, does this thing match? If it matches, let's append it. Like, so does the thing work? Then let's append it. That's the way we were doing it before. Now we're going to flip this upside down. We're going to have one, and the reason this was a problem was because, remember, the way we started out here, if they were searching for both, we would risk appending it twice. If it would match here, we'd append it here. And if it would match here, we'd append it here. This is a problem. Well, what we're going to do is we're going to make things weird, and we're going to append just once at the end. All right, now we've removed all these append statements. Okay, and what we're going to do instead is change everything. We're going to basically, before we were seeing if the thing was good and we were appending it. But really the problem was we weren't sure it was completely good until we checked all of the things if they were searching for multiple search terms. So now what we're going to do is we're going to reverse the logic and we're going to look if it's bad. All right? I want you to envision there's an assembly line and there's a bunch of, there's 5 checkpoints on it and there's like a bunch of people picking the thing up. Does it look right? Or you're just eyeballing it and they're looking for problems. And if they find something wrong, they're going to throw it out if it's a reject. All right? So pretend you're that person. And now what we're going to do, if they're looking for description, this part stays the same. But if the description lower is not a match, if it's bad and it's a problem, instead of appending it, I'm going to say continue. What continue does is it's just going to say, no, move along, move on to the next item. It's going to look for the nearest for loop that's backwards, and it's just going to move on to the next item in the for loop. It says this one is a dud, send it on its way, throw it in the trash can. It's not going to get appended. All right, so now we're doing this. We're looking for problems instead of looking for goodness, and if it makes it through all of this stuff at the end, if it makes it through the entire assembly line and there's no problems, then it must be good. All right, you guys following the logic there? All right, my weird analogy, and it used to be more, but I made it. So if you're looking at robot hands, all right, and you're making robot hands, and you see one of them and it's missing an index finger, you're gonna throw that hand out. All right, you're just gonna throw it out. You don't need to check the other 4 fingers if it's missing an index finger. All right, that's the idea. We're saving our program time here because as soon as we find a problem, we know it's not good. We don't need to keep checking all these. All right. Pretty weird analogies. Like a gatekeeper. Yeah. So anyways, let's continue. This one's a little trickier because we can't just kick it out with the file name because we have to finish the entire for loop and then kick it out. All right. If there's a problem. So the way we're going to solve this, because we're short on time, I'm just going to show you. I'm going to create a variable. And what I'm going to say is, I'm going to call it matched. It's going to be a Boolean variable. I'm going to set it to false. If we find a thing, remember here we said append before. We can't append it yet because, remember, we're appending all the way down here. And we're just trying to find if there's a problem. There's a problem if we never enter this if block. If we go through all the files and we never find a match, we never enter this, then it's bad and we need to continue. So I'm just going to say if we do find it, I'm going to update this matched variable to true. So every time we start out looking for a file, for each gist, we're going to set this guy to false and reset it. And we're going to loop through them. If it's a match, we're going to overwrite it to true. And we're going to break and leave the for loop. We don't need to keep checking the files. If we find that one is good, it's good. Finally, after the for loop is done, if we still have not found a match and this variable is still false because we never entered this if block, then if not matched, remember that's like saying if it's false, then we just continue. So what we've done here, I'll go over this again in a second. But high level is another weird analogy. I have really bad analogies for this lecture. I'm sorry. But my other analogy is you're creating a minefield for your program to go through. And these are all little mines that it could hit or something. And if it gets through all this stuff, it's good. All right. And so that's kind of, I have the worst analogies. But they're memorable. So that's what counts. So anyways, we're going to check each of these guys. If the description, if they care about it, then we're going to see if the filter works. If we're looking for problems now. So again, if they're not searching for description, this will be false. We won't even check this side in the end. We won't hit this continue. If they are searching for description, we'll check and we'll look for problems in our assembly line. If this is not a match, we'll continue, move on to the next item. Same thing for file name if we're looking for it.
What if it is a match?
If it is a match, we just keep going.
Okay. And continue means it goes to the bottom, or it moves on to the next item in the for loop.
That's correct. So it goes back to the nearest for loop behind it and just move on to the next item. Perfect. So it's just saying next one. And then so basically the way this is working is if it doesn't hit either this continue or this continue for either of these parts, it's good by that logic. And if we're doing a file name, we'll set this extra variable called matched to false so that we can keep track if we found it or not. If we do find it, we set it to true. But if we get through this entire for loop and we never enter this if block and change the variable to true, and we left it at false there, that means we never found it, it's bad, matched is still false, we can hit continue. So if it makes it through both of these hurdles, it's good. Does that make sense to everybody? It's weird, it's not intuitive to think about it this way, but it works. And honestly, and it works really well. If you can imagine, we only have to have one if statement for each condition or each default parameter that we have here. So if we have 3 optional arguments, it's only 3 if statements. Whereas before, the way we showed you last time, it would be 8 if statements. So as you can, and we're not repeating ourselves in terms of code. We've only got the logic here once and the logic here once. So it's a lot faster. It executes faster because, again, as soon as it finds a problem, it moves on. It doesn't need to check all of these guys if it doesn't need to. And ultimately, it works. So if I save this and I run this, and if I run it without this, all tests are now passing. And if we go back here really quickly just to show it, Python main.py, Santiago Basulto, -d time, and I forgot the U. Oh my gosh. All right.
Rookie mistake.
I did it on purpose. And so we can see here that apparently main, the part we weren't really paying attention to, is abstracted to kind of display these particular keys in our JSON file for each gist. And so it's working. This is from the internet. We just use the internet with Python. Pretty cool. The real tricky thing was about this part. This is tricky. Kind of getting familiar with the imports can be tricky. One quick thing about imports I want to say is, remember, you might not always import or see all of the functions in here, but generally speaking, our test.py file will have everything because it's going to be importing all of our functions so that it can test all of the functions. It's going to import all of the data we need, all the test data we need. For example, it's just a file loading our JSON file. It's loading this basically, so I can run the test with it. So most of the time, you can expect the test file to have everything imported that you might use for the most part. So it's pretty cool. Any questions? So it will work. That's a good question, Andrew. Main.py. So this is not outputting this utils part here. All right, this is not being executed when I run main.py. It's actually running something similar right here. So yeah, gotcha. It's a trick question. But yeah, that is not being executed right now. Only if I hit run here, it'll run something different. Notice this is different format than if I run my previous command here. Different data format. So it's a different thing. Any questions with that today? I recommend you guys like look over this. Remember, the link is in the chat. I'll link it again. I recommend you look over this at some point. Just familiarize yourself. And remember, like today, we started not from scratch. We were looking at somebody else's code, and remember how I kind of looked around at all the files, looked at the imports to kind of get an idea and familiarize with myself how things were working. Read the README, read the tests, did all the things I needed to do and made sure how this function worked before I used it in my function I was going to write. All very important. If I didn't ever do this part, I wouldn't know that maybe it returns none sometimes, and I would have missed this part. But that's kind of the idea from today. Any questions with that? All right, hold on. Oh, they changed the animation finally.
Yeah.
Oh.
It's
All
way
right.
cuter.
Yeah, it was pretty bad before. All right, so here's us today. Next class is Wednesday, and it's a particularly difficult class, I'm not gonna lie. So please have a nice meal before that. Be rested. I am actually going to have Santiago fill in for me that class this Wednesday coming up. It's my birthday. I'm going to be celebrating.
Happy birthday.
Thank you. And I will also probably be missing next Monday. Santiago will also be filling in for me there. But don't worry, he's just as weird. So.
That's a good question because next Monday is Labor Day holiday, so we'll still be here, correct?
I believe so. Yeah. I will double check that. Unfortunately, our schedule, I think we'll still be here.
Nice, Jordan.
Thanks, Jordan. Selling me out. But yeah, try and get this done, and there will be another weekend project, but Santiago will cover all that. So I will probably see you guys in a little more than a week. Stay strong. And Santiago should be pretty good at explaining this guy, so I'm not too worried about it. Thank you.
Thanks for everything, and happy birthday.
Yeah, I recommend you guys read the Zen of Python if you want to fall asleep. And remember, yeah, I don't know. Have a great weekend or week or whenever I see you guys. I will be back. And be sure on Wednesday to say bye to Jordan. He'll still be around in Slack, but give him a high five or whatever you can do.
It's a terrible time.
I know. Don't worry, you get another cool TA. Don't worry about it. You get to meet Andrew. All right. Have a great week, everybody. See you. Well, not see you Wednesday, but you'll have class Wednesday.
See you, Jordan. See you, Jason. Thanks.
Adios.
Bye, everyone.
Bye-bye.
Bye.